Welcome back to the instructional video series on hierarchy of energy theory, where we unify all physics under one physical model. I am your theory influencer, Scott Gordon. In lesson 1, we showed that trying to find the theory of everything through experimentation or mathematical derivation bypasses the foundation of physics, leading to failure. The path to the theory of everything starts with knowing exactly what space-time is made of. In lesson 2, we took the ultimate reductionist approach and reasoned that a spinning point satisfies the criteria for creating a building block of space-time. This spinning point has a different structure along two directions, the radial direction of its spin and the axial direction of its spin. In lesson 3, we constructed a one-dimensional space-time and revealed how the distance emerges from the fundamental building blocks where energy is required for their alignment. We defined a dimension as the alignment of energy along an independent direction. We also introduced the quantum distance, where the quantum distance is a relative distance and is relative to the energy along the path. In this lesson, we apply what we know about the one-dimensional universe to create a two-dimensional universe and a three-dimensional universe, and then look at the inevitable consequences predicted by space-time's internal structure. The one-dimensional universe is constructed by a linear alignment of building blocks on each other's primary plane. To have equal energy along the line, the building blocks must be stationary and equally spaced apart, where each space represents a quantum distance. To create a two-dimensional universe, we add more building blocks. These building blocks are not arranged linearly, but are still aligned with their primary planes on the same plane. Each added building block interacts with every other building block already in the universe, and it requires energy to bring building blocks relatively closer to each other. To have energy balanced across each building block on the plane of building blocks, the pattern would have to be that of a hexagon. In this pattern, each building block occupies an equivalent position within the pattern as every other building block in the pattern. Each building block is surrounded by 6 building blocks, and they are all spaced a relative quantum distance apart. Inherent in the hexagonal pattern are groups of lines that are aligned in 3 different directions. The lines in each group are parallel to each other. Each line looks very similar to the line of building blocks that make up the one-dimensional universe. With 3 linear directions on this plane, you may ask, does this structural alignment represent a 3-dimensional universe? Great question, and the answer is no. But why? Well, here's why. A dimension is defined as the alignment of energy along an independent direction. The directions of the lines within the hexagonal alignment of building blocks do not represent directions that are independent from each other. But why? What makes a direction independent? And how many independent energy directions are there on the plane? We can find the answer by using the structural properties of a space-time building block. We know that the axial direction of a building block represents an independent direction. It is independent from all the radial directions that are possible on the building block's plane of spin. We are going to use this property to find how many independent directions exist on the plane of spin. Consider any line along the plane going through the building block's spinning point. Now make this line a new axis of rotation. As we rotate on this new axis, we also rotate the primary plane. But the line we chose remains on the plane whether the plane is rotated or not. This line is represented in both the original plane and the rotated plane. As we rotate the primary plane, we find a line on the rotating plane that will align with the building block's original axial direction. Since we know that the axial direction is an independent direction, then this direction of the rotated plane will be independent of the direction of the line we chose on the plane. There are no other directions that can be made to exist independently from each other using these building blocks. Note that we could have chosen any direction on the plane of the building block. The results would be the same. Therefore, a plane contains 2 and only 2 independent energy directions. These directions are represented by a 1/4 rotation or a rotation of 90 degrees. The planar universe contains 2 dimensions and is created when space-time building blocks are planarly aligned in the hexagonal pattern. Since it didn't matter what direction we used on the plane, any direction that is rotated 90 degrees from any line on the plane is an independent direction in relation to that line. Note that the axial direction of all the building blocks exist. This direction can be considered a true hidden dimension. because it represents a potential independent direction, but there is no energy creating distance along it. To align energy along this direction, a space-time building block would have to be oriented where its plane is aligned in that direction. When using space-time building blocks to build space-time, the maximum number of independent energy directions is 3, and therefore the maximum number of dimensions possible is 3. So what would the alignment of building blocks be to create a three-dimensional universe? Well, we know that each building block would be interacting with every other building block in the universe. Each building block would have a position where the energy surrounding it would be balanced. And the position of each building block would essentially occupy an equivalent position in the pattern as any other building block. Using these criteria, the alignment of the building blocks for the three-dimensional universe would be that of a cube, where the center spinning point of a building block would occupy the center point of each face of the cube. Its primary plane will be aligned on the face of the cube. When the spacings are equal and the blocks are stationary, the energy density along all directions would be equal. Now that we have energy equally distributed within each quantum cube volume throughout a cubic arrangement, the energy density along every direction is the same. Therefore, a quantum distance can exist along any segment of the line within the three-dimensional universe. And the quantum distance remains discrete because the stationary building block is still essentially responsible for the presence of a quantum distance along the line. Now the question is, how do we combine independent energy directions, or how do we combine distances along different dimensions? Surprise! It's the Pythagorean equation. Actually, that's not much of a surprise. But what will be a surprise is that this equation also represents how to combine energies that are in different dimensions. We'll come back to this aspect of hierarchy of energy theory in later segments. Hierarchy of energy theory's model proposes space-time as an energy medium consisting of 3 independent energy directions, which are responsible for our 3 dimensions of space-time. This model has many consequences, and here are a few that indicate we are heading in the right direction towards a theory of everything. For example, if we assume that there is not an infinite number of space-time building blocks, then when space-time building blocks would repel from each other, the region they occupy would relatively increase. We see this as inflation of the universe. In addition, the building blocks will not retain an equal energy balance everywhere in the universe, creating energy gradients within the space-time energy medium. These energy gradients results in particles that exist in space-time to move to regions of space-time with less energy. We see this as expansion of the universe. Oh, and spoiler alert, the cosmological constant, not constant. Space-time is a dynamic sea of energy. We looked at the simple model of stationary building blocks, but the building blocks of space-time are not stationary. They're moving, jiggling, and wobbling in their positions within their lattice, while their lattice itself is shifting, writhing, and undulating. This constant turmoil affects the relative quantum distances within space-time, and we can demonstrate this by using a one-dimensional universe. In an infinite line of building blocks, we can make groups of 4 building blocks where the first and third building blocks remain stationary, and the second is shifted 1/2 space to the left, and the fourth is shifted 1/2 space to the right. It will require energy to shift the building blocks, but how much energy? To stabilize that line containing displaced building blocks, we would need to add 2 more building blocks for every 2 building blocks that are already on the line. That would restore the balance of energy density along the line. Adding these 2 building blocks for every 2 building blocks along the line would double the number of building blocks on the line, and therefore double the amount of energy on the line and half the quantum distance. Now, instead of adding more building blocks to restore balance, we can just let the second and fourth building blocks oscillate. The fixed first and third building blocks would remain stationary. However, the energy along the line would still be doubled. This demonstrates that moving building blocks are associated with more energy than if they were just stationary. The quantum distances along the path are related to the energy along the path, not just the number of building blocks. This is an important concept in hierarchy of energy theory and will play a major role in the theory of special relativity. Instead of thinking of space-time as a network of measuring rods and clocks, we need to think of spacetime as an energy medium, where the energy density of spacetime determines the relative distance and the relative time within spacetime. In summary, spacetime is composed of a spinning point as its building block. Using the building block of spacetime, we can only create a maximum of 3 spatial dimensions. Spacetime is a dynamic sea of energy. The energy density of spacetime determines the relative quantum distances within that region of spacetime. Now that we have a fundamental understanding of spacetime, we are ready to relearn the entire field of physics from the bottom up. And we'll start with this question: what is light? That is the topic of our next few videos. There are many exciting and fascinating surprises to come, so hang in there. If you are curious about this novel approach to find the theory of everything, then click the like button below and subscribe to this channel so you can be notified when future lessons are released.